Hello all. So this is a sixth lecture of operators in C. In this lecture we will see mainly conditional operator and size of operators. So operator is a symbol. So we have already seen arithmetic operators, relation operators, logical operators, bitwise operators, assignment operators. In this lecture we will see the miscellaneous operators. So in that miscellaneous operator, we will see the first one is size of operator. So it is a unary operator. So unary operator means it has only one operator. So plus is a binary operator because we require two operands, A and B, A plus B. Here size of is a unary operator because it requires only a single operand. So what it does is it returns the size of data. If we are giving constant, it will give the size of that constant, or variable size, array size, structure. We will learn about array structure, etc. later. So it is mainly used when we learn array pointers and all. We will be using the size of operator. So I'll simply show the size of operator with a program. We have already seen this program, but I will once again show that program. So I have already written this program. So I'll just open that program. It is size.c. So I have written this program. There is hash include stdio.h. Now I have included this as hash include limits.h. So I'll just remove this line. Okay, I'll just comment this line now. So I'll just comment this line. We will see what happens if we comment that line. Then we have this main program. So hash include std. We have this main program. We have some few printf statements. In the first printf, it is printing storage size for int equal to percentage %d, and we are using the size of int. Inside this we are giving, inside brackets we are giving int. Here we are inside bracket we are giving char. Then here we are giving unsigned int. So we are giving float here, we are giving double here. Okay, let's see without this. So now we have to compile this. So for that GCC, there are some warnings here. So warning is, instead of percentage %d, we have to use percentage %lu. So it stands for long unsigned int. Okay, so long unsigned. So we have to, instead of int, we have to use unsigned long. So that's an error. It's a warning. Even though you will get the result, it's not an error, but it's better to use that thing. So we have to replace everything with percentage %lu. So it was mentioned that you have to use percentage %lu instead of percentage %d. Okay, so we'll replace it with percentage %lu. So I have changed this to %lu. Percentage %lu. Then this line here, percentage %lu, and here also percentage %lu. So I have changed all those to percentage %lu. Now I will again compile this thing. So when I compile, there is no error. Okay, GCC size.c, we have no error. Now I'll run this using /a.out. So you can see that the storage size for integer in this compiler or in the system, it is assigning 4 bytes. For character, it is 1 bytes. For unsigned it is 4 bytes. For float, it is 4 bytes. And for double, it's 8 bytes. So that's the use of size of operator. And even if you want, you can use in a different manner. So for example, if I am going to declare here int, I am simply declaring int a. Okay, int a, and I am simply giving it in I am simply declaring a variable a, And if I want to find the size of A, instead of giving like int, I can simply give size of A. Okay, and I'll simply change the print statement also. I'll simply change the print statement to this. So we are taking the size of a variable. So I have mentioned we can get the size of a variable, a constant, an array. So here I am checking the size of a variable. So we have to simply give inside a bracket, inside the bracket. Okay. So I'll run this program. So I'll again compile this and I'll run this program. You can see this storage size for A. For that variable, we are allocating 4 bytes of memory. So it is 4 bytes of memory for that integer. Since it is A is an integer variable, it is allocating 4 bytes of memory. So we can use in that manner also. Okay. So that is about size of operator. Uh, we have seen the examples. Then there is another operator. This is question mark and colon. We call it as conditional operator. This is conditional operator. So this operator is known as conditional operator, question mark and colon. So this is the general syntax for that. We have some expression. So it can be any expression. It can be a relational expression, logical thing, a greater than b, or anything you can give. Or simply you can give a equal to 5 or anything. After that some question mark and there is another expression. After that there is column and there is another expression and it ends with a semicolon. So if you are giving this kind of operator, so what is the use of this operator is how this operator gets evaluated is, so first it will check value of a question mark expression is determined like this. So value of this operator is determined like this. So value of a question mark expression is determined like this. If expression 1, so what it does is expression 1 is evaluated. So expression 1 will be evaluated first, and if it is true, then expression true is evaluated and becomes the result of the entire expression. So what this operator does is you remove this a, there is no need for this a. So what it does is expression 1 is evaluated first. So when we give a statement like this, expression 1 is evaluated, and if it is true, then what it does is expression 2 will be evaluated, and what we get as result will be the result of the whole expression or the whole entire expression. And if expression 1 is false, so if expression 1 is false, then expression 3 is evaluated and its value. So and the value of this expression 3 becomes the value of the whole expression. Okay, I will show an example, then you will understand what is the use of this operator. So I am going to type a new program. Vim, I'll call it as condition.c. Condition.c. I am going to type a program as include stdio.h, then int main. Then I'm going to declare some variables. Int a equal to 10. I'm initialize that value also, and also I am declaring another variable p. Then in the next statement I am going to use the conditional operator. So what I am going to do is I am going to use a conditional operator. So here I am going to include an expression a double equal to 1. So you have already seen this is a logical expression. So a equal to 1. Then I am going to use the operator question mark. Then I am going to give 20. Then I am going to use colon 30. Now I will explain what happens here. So here I have initially given a's value as 10. Now what this operator does is, this is a conditional operator. This is a ternary operator because we have 3 operands. This is also known as a ternary operator because we have 3 operands. This is the first operand. This is an expression. Okay. then this is the second operand and this is the third operand. So what it does is it evaluates and that value will be assigned to B. So how this evaluation happens? So we have already seen, so this expression will be evaluated first. So we will evaluate this expression. A's value is 10. So 10 double equal to 1. So it is a comparison. We will get the value as false. So since it is false, this won't be evaluated. So this value will be taken. So 30 will be assigned to A. So we will print it and see. Then you will understand. Printf. We will print it. I'll call it as line 1 because I want to show another example. So line 1 value of B. So I'm going to print value of B is percentage %D and comma I'm going to print B. I'll just close it. So I'll stop it here with this program and I'll just save it and quit and I'll compile it. GCC condition.c. So then I'll run this program a.out. So if you run this program, you can see that value is 30 will be printed. Okay, value of 30 will be printed here. So we have got the result as 30. Why that 30 has come? Because we will check for the first expression. If it is true, then this 20 will be the result. But here this is false. A is 10. So 10 not equal to 1. So it is false. So since it is false, this expression, if there is some expression here, then that expression will be evaluated. But we have given simply some value 30. So that 30 will be taken as a value of the whole expression. So 30 will be assigned to B. So when we print this, we will get as 30. Okay. Now I'll add one more statement. I'll check for the true statement. True. For the first expression, if we get to valid, I'll make it /n. I'll include /n. And I'll copy these two statements again. Okay, I'll copy these two statements again. And I'll simply do it here. I'll copy it here. Now I'll change the value here. I'll change the value. Instead of 1, I'm going to give 10. Okay, I'm going to give 10. So instead of a equal to 1, I am checking whether a equal to 10. So here initially a is 10. So this a equal to 10, it is true. Since this expression is true, this 20 will become the value of the whole expression. So when we print this, you should get 20. So for the first line, you will get 30, and for this expression, the value will be 20. So I'll again compile it and again run the program. You can see that the first line, it is value is 30 because the expression 3 will be evaluated. The second line, expression 2 will be evaluated and that will be the result. So expression 2 is 20. So this is the use of ternary operator. So always, so if you want, you can input three numbers and check which one is greater. So simply use it inside this expression. You have to check a greater than b. If a greater than b, you have to check another b greater than c. Like that, you can check whether which is the largest among three numbers using the same ternary operator. Okay. So what it does is we have three expressions. So if the first expression is true, then the second expression will be evaluated and that will form the result. Even though we have given simply a value, so we can give expressions also. If the first expression is false, then the third expression, we will not do anything with the second expression. We will evaluate the third expression and the result will be shown. So that expression will be evaluated and the result will be shown. Okay. Now we'll come back to the slide. So that is all about this operator. This is conditional operator. This is a ternary operator. We have three operands here. Okay. Next, we have other miscellaneous operators also. We will study all these miscellaneous operator later. So size of operator returns the size of a variable. So size of a, if a is an integer, we will get a value 4. This is known as conditional expression. So if condition is true for the question mark, then value of x will be taken, otherwise value of y will be taken. Okay. Then ampersand, this is another miscellaneous operator. So it returns the address of a variable. So if we give ampersand a, it means we will get the actual address of the variable. So we know that when we declare a variable, that variable, if we are declaring int a, so that a is an integer and that will be allocated 4 bytes of memory in some address location, maybe 5000, at 5000 address location 4 bytes of memory will be allocated. So 5000 to 5004, so for that we can use for variable a. So if you want to find where that address is, you can use this ampersand operator. So we will learn about this ampersand operator when we learn pointers. So I'll simply show an example now. Don't be confused. If you are confused, you just can leave this operator at present. Then we have asterisk, or we call it as pointer to a variable. So it is star a. I will show an example program, then you will understand the use of this operator. So I'll write a program, vim, I'll call it as pointer dot c. Okay, so I'll write a program hash include stdio dot h, then int main. Okay, then I'm going to declare a variable int a equal to 4. So I am declaring a variable and I'm assigning a value 4 to that variable. Now I am going to declare a pointer variable. So you need not worry about this pointer variable. We will be learning about this pointer later. So I can give name anything like you have used a as a variable name. I am using a variable name as ptr. So ptr is actually a pointer variable. It is not an ordinary integer variable. It is actually a pointer to integer variable. So this is used to store. I am declaring this to store the address of this a. Okay, so I am going to store the address of a in this pointer variable. I am not going to store the value of a. I am going to store the address of a. So I have already mentioned that you can use ampersand symbol to give the address. So we have used this address operator in scanf also. So scanf, you will be using ampersand a. So ampersand a means you will be storing that in the address of a. So ampersand a gives the address of a. So this is a gives the value, that is a variable. So if you want to, that a will be stored in some address location. So if you want to get the address of that, you have to use the ampersand operator. So when you say ampersand a, you will get the address of that variable. Now I'll just print it. I'll just print value of a. I'll just print value of a is it is percentage d. This is ordinary print only, and I'll use slash n also. After that I am going to print a. Okay, so I have simply printed a, and if I want to print a, there is another way to print a also. So that is, I will be printing star ptr, or I'll simply value of star ptr. I'll simply print the value of star ptr. Okay, I just want to print the value in ptr. So ptr is actually an address location. If I want to get the value of star ptr is percentage d. Okay, I'll give slash n, and I'm going to print ptr. So if I want to print the value in ptr, I can use this star ptr. So that is the use of the star operator. So PTR is actually an address location. Okay. So PTR is actually an address location, and if I want to print the value in that PTR, you leave it. I'll just mention another way. So I'll just print the address. We'll print the address of that A. After that, we'll come into that. So I'll just print value of, or so I will just print address. You leave it at present. So I'll address of A. So if I want to print the address of A is, so we have already seen this. We will first try for percentage %d. We will see what happens if we use percentage %d. And I'm just printing PTR. So what I have done is I am printing value of A. I am printing A first. Then after that I am printing PTR. Okay, PTR. So we will see there will be some warning here. GCC pointer dot C. So there is a warning here. We should not use percentage. Okay, since it is a pointer, we should not use percentage here. But it's okay. We will run with that. We can see whether you'll get any output. Otherwise, we will change that thing. Okay, so we'll get an address here. Maybe this may not be correct because we have not used. So I will just change this percentage %d to, so I will change it to percentage. Since it's a pointer, there's another format where percentage %p is there, or you can use other things also. I'll use percentage %p. Need not worry about this thing. I'm using percentage, percentage. So I'll use percentage %p here. Okay, instead of percentage %d, I am using percentage %p. So what happens? We will get the address here. Okay, you need not worry about percentage %p and all. We'll learn about pointers later. In fourth module, we'll be learning about this thing. So I have just compiled it and I'm running this. So you can get the value. The first line, value of A is printed. Now in the second line we are printing the PTR value. So we are getting some hexadecimal value. So this is actually an address location. It is some address location in the memory. So A is in this address location. So that 4 value is stored in this address location. Okay, in the memory you can see the 4, there will be 4 bytes allocated for that variable A, and it starts from this address location. Okay, so this is 0x stands for hexadecimal. So this is a address location. Okay, now I'll show another. We have already seen ampersand operator. So ampersand operator gives the address. So you are storing the address in PTR. So you can store in a pointer variable. PTR is actually a integer pointer variable, pointed to an integer variable. So we'll learn about it later. Don't worry. Now we will print. We have also seen another operator here, that is star. It is a pointer to a variable, so it is another operator is there. So we will see how to use that star operator. Okay, so for that I'll just print one. I'll include one more statement. I'll just copy this statement. Okay, I'll just print it here. I'll copy it here. Now I am going to print, instead of printing A here, so value of here, value of A is percentage %d, and we are printing A here. So instead of printing A, I can also print like this, star PTR. Okay, so instead of printing A, I can also use star operator. So this is the pointer to that variable, star PTR, star PTR. So if you print like this, if you give star PTR, then also you will get the same effect, that is value of at that pointer. So this means star ptr means ptr is actually a pointer variable. So you are asking star ptr means you have to print not the address, the value at ptr. So value at ptr is actually 4. Okay, so we'll run this program. Now I'll compile it and I'll run this program. You can see that here the first statement is printed. Now it is in your address location is printed. Now you can see that the address has been changed because it is in RAM. So RAM is in constant use. Some other we are getting some other address location now. So it is now different address location from the previous one. Again, if you run, it will be some other address location. So you'll get the address here. Now we are printing value of A. You can use %A or you can use star PTR. So A is equivalent to star PTR, or if you are giving star PTR, then also you will get the value in that address location. Okay, so you will get the, so the star PTR denotes, PTR is actually an address. So star PTR denotes the value at that address location. Okay, so that is the use of this ampersand and star operators. So you will learn about these two operators when you learn pointers. That's why I have marked that as bold in these two lines. So you can, as of now, you can leave these two statements. Ampersand and star we will learn in detail in fourth module. So you will leave at present. Okay. Thank you. So one more thing is there. Then there is some operator precedences there. So we have seen all the different operators in C. So this is a operator precedence. So this is a highest precedence. So precedence goes on like this. So this category. So postfix operators, all like in whatever inside the parenthesis. So all those will be expression in square brackets. This thing, this operator, then dot, plus plus, increment, decrement. Okay, all will be, actually these will be post increment operators. Okay, this is not pre increment. We have already seen post increment and post decrement. So post increment and post decrement, and the associativity is from left to right. So the expression, so we learn about expression, then you will understand what is this associativity. So it is from left to right. So it starts from, evaluates from left to right. Then we have unary operators like plus operator, minus, this is plus 25. If you are giving minus 6, it is not the addition operator, it is unary plus unary minus, then unary not operator, all this tilde, then plus plus. This is actually pre-increment operator, pre-increment, all this. Then type, we will learn about this type later. Then star, ampersand, we will learn all these operators later. Sizeof also we will learn about this operator. So this has the next precedence. So after this postfix operator, this should come. Like in mathematics, you have that BODMAS rule, brackets, then bracket, division, multiplication, addition, subtraction, like that. So here also there is some order in evaluating an expression. So if some, all these operators come in an expression, so the highest precedence is for this operator, these operators, then second highest, then third it is multiplicative, that is star, division and modulus operator. The associativity is from left to right. Then addition and subtraction will come next. After that, shift operators, then relational operators, equality operators, then bitwise and, bitwise XOR, bitwise OR, logical and, logical OR, then the conditional operator, then assignment operators, all the assignment operators, and finally the comma operator. So this is a precedence rule. So highest precedence is all these operators. So we will see expressions in the next lecture, and you will understand what is this precedence. So there should be some order. If we have all these operators in a single expression, then there should be some order of evaluation of these operators. So this is the order. So this will have the highest, and comma will have the smallest preference or the lowest preference. So we should evaluate from these operators first, then this type of operator second, third set, like this. It will go on like this. Okay. So we will see about expressions, and you will understand what is this valuation or this operator precedence. So thank you.